In this problem, 22 bottles are randomly selected and the quantity of apple juice in each bottle is measured. From this random sample, we calculate the sample mean to get an estimate of the population mean of the mean amount of juice in all of the bottles. We don't want to underfill because of the severe punishments we would suffer. We don't want to overfill either. We are aiming for 64.05 ounces. We need to make a decision with quantitative data. If the conditions are met, we can do a hypothesis test for the population mean. Do we have a random sample? Yes. Is either the population normal or we have a large sample size of at least 30? We have a small sample size of 22. So we will need to make a probability plot to see if the sample is skewed and a box plot to check for outliers. Our probability plot and box plot tell us that our sample is normal with no outliers. So it is reasonable to assume the population is normal. If the population is normal, then the sampling distribution for the sample mean is normal, which is necessary for this method to be valid. We know the value of the population standard deviation is 0.06 ounces. This can actually happen in manufacturing where the calibration is off, thus the population mean is unknown, but the variation is unchanged. Thus, the population standard deviation is known and unchanged. Before you take your random sample, you are supposed to set up your hypotheses and decide on a significance level. The null hypothesis is the status quo, where nothing unusual is happening. It's what everyone thinks the population mean is equal to. The null hypothesis always has the equality. So it has to be the population mean is equal to the hypothesized value of 64.05 ounces. Now, we don't go with the null hypothesis. What is our alternative? The alternative hypothesis. It disagrees with the null hypothesis. All you need to figure out for the alternative hypothesis is which inequality to put in there. Put in whichever one the researcher wants. In this case, the quality control manager needs to know if the population mean is significantly more or less than 64.05 ounces. Use the not equal. This manager wants to use a significance level of 1%. So our p-value would need to be 1% or less before we can say something unusual is happening. Alpha is the probability of a type 1 error, which is when you go with the alternative hypothesis and you're wrong. That would mean we shut down the assembly line to recalibrate the machine when it was not necessary to do that. That's not good. A type 2 error is when you go with the null hypothesis and you're wrong. The machine needed to be recalibrated and we missed it. That's not good. From a random sample of 22 bottles, we got a sample mean of 64.01 ounces. Is this significantly different from the 64.05 ounces? Let's find out. First, let's go over the logic behind this hypothesis test. You should do this on every homework problem that you do. If you are unable to explain this logic, you do not understand hypothesis tests. That may sound harsh, but someone has to say it. First, let's draw a picture of what the sampling distribution for the sample mean would look like if the null hypothesis were true. Its shape would be normal because the population is normal. Its center would be 64.05 if the null hypothesis is true. Its spread is equal to the population standard deviation divided by the square root of the sample size. Now, take your significance level and put half of it in the left tail and half of it in the right tail, because this is a two-tailed test. The red areas are the critical regions. If we get any of these sample means, that would be too unusual if the null hypothesis were true. So we would reject the null hypothesis and accept the alternative hypothesis. We see there is a 1% probability of being wrong about this. This blue shaded area represents 99% of all the possible sample means we could get if the null hypothesis is true. If we get any of these sample means, we have no evidence that anything unusual is happening. So we have no reason to reject the null hypothesis. This doesn't mean the null hypothesis is true, but you don't have evidence to say it's false. This is a subtle but important difference. That's why we say fail to reject the null hypothesis. We never say accept the null hypothesis. A hypothesis test does only one thing: finds evidence to support the alternative hypothesis. Either it finds it or it doesn't. So you either have sufficient evidence to support the alternative hypothesis or you don't, period. We will use the p-value approach in our TI-8384 calculator. Press the Stat key, then the right arrow key twice to highlight Test. Z-test is used since the population standard deviation is known. If the population standard deviation was not known, we would use t-test. Press 1 to select Z-test. Highlight Stats and press Enter. Press the down arrow key and enter in the hypothesized value for the population mean, 64.05. Then enter in the value for the population standard deviation, 0.06. Enter in the value for the sample mean, 64.01. Be careful. Don't get your two means mixed up with each other. This one is the hypothesized value for the population mean. This one is the sample mean. Enter in your sample size, 22. Use your arrow keys to highlight the inequality used in your alternative hypothesis, not equal. After it's highlighted, press Enter to select it. Press the down arrow key to highlight Calculate and then press Enter. The first line tells us we used Z-test. The second line shows what we entered in as our alternative hypothesis. Double check that it matches. The third line shows the value of our test statistic. You should always think about what this is telling you in every homework problem you do. Our sample mean is 3.12 standard errors below the hypothesized population mean. If the null hypothesis were true, is that unusual? That would be very unusual. The fourth line tells us the probability of how unusual this would be if the null hypothesis were true. In other words, the p-value. There is only a 0.0018 or 0.18% probability of getting a sample mean this far away or farther if the null hypothesis is true. Is this sufficient evidence to support the alternative hypothesis? It is if the p-value is less than the significance level. Our p-value of 0.18% is less than our significance level of 1%. So we will reject the null hypothesis and accept the alternate hypothesis. There is sufficient evidence at the 1% significance level to support the claim that the mean amount of apple juice being dispensed is different from 64.05 ounces. They should shut down the assembly line and recalibrate the machine. If we are wrong about this, it's a type 1 error. Isn't it nice to know there's only 1% probability of making this type 1 error?